Alright, okay, so this is proof 4 of 5. We're getting to the harder ones now. Okay, so now I see this, you guys keep getting this mixed up. Do not mix up parallel lines and congruent segments. This here means parallel. This here also means parallel. Okay, so I'm going to write the givens. JK is parallel to LM. JL is parallel to KM. This is given and this is given. Okay, so usually when you're given two parallel lines only, you want to try and find angles that are congruent to each other. So we went over corresponding angles or alternate interior angles. Those are the most common ones that come up. I would say alternate interior angles comes up way more often than the other. Okay, but based off this, do not assume that these are congruent to each other. I've seen that mistake too many times. Just because it's a parallelogram, you can't assume that the sides are going to be congruent to each other. I know we just went over that recently in module 9, but you cannot make that assumption based off what you're given. If you're only given that these are parallel, you cannot assume the opposite sides are congruent. Okay, so this part here, JK is congruent. JK is parallel to LM. Okay, so the first thing I see is if I have this here, what we know is this angle is congruent to this angle. Okay, if I draw the out the transversal and the two parallel lines, this is from module 4. Module 4 says that the interior angles between the two parallel lines on opposite sides are congruent. So that is called the alternate interior angles theorem. Okay, so these here are alternate interior angles. Okay, we also know that JL is parallel to KM. Okay, so we have another pair of alternate interior angles. It's these right here. Okay, angle JLK is congruent to MKL. Yep. So these are alternate interior angles as well. So what we did earlier, we identified angles that are congruent. We also identified another pair of angles that are congruent. So that's the naming convention there. Okay, the next step I see, I'm looking for a side that is shared between both triangles. I believe this one in the middle will work. So therefore, segment KL is congruent to itself. So this is the reflexive property. We identified a pair of sides that are congruent, so those are going to be congruent. Here, this part, step 6 now. Okay, so if we look at these two triangles, if I were to draw them separately, okay, if I were to draw these separately, these triangles are going to be congruent by angle, side, angle. The side is included between the two angles. Okay, so based off this, I see triangle JLK is congruent to triangle MKL, and this is going to be congruent by angle, side, angle. Okay, and the last step here, we're proving that certain sides are congruent to each other. Since we're not proving triangles, if you prove that triangles are congruent to each other, it's going to be this step here. Because we're proving sides are congruent to each other, it's by default going to be CP/CTC. So corresponding parts of congruent triangles are going to be congruent. Okay, so now you can say those are going to be congruent to each other. Do not make that assumption from the start. Okay, this is proof 4 of 5.